I love space. I always have done. I grew up reading lots of science fiction. I was always interested in the questions it asked at the edge of our knowledge and understanding. All stories invite us to ask questions of ourselves. What would we do if we were in the shoes of the protagonist? But science fiction takes that what if even further. What if we could travel between the stars? What if we came into contact with aliens? What if we could build a time machine? I want to talk about some what ifs, but also some if-sos. I believe that space science and technology has already given us the means to solve many of the problems facing life on Earth today. If so, we should be educating people on how best to use those means. My love of space and science fiction led me to study science, and in particular physics. I was interested in the big questions. How did the universe begin? How do we know what we know about the Big Bang? What are we? Beyond the philosophical and biological questions of what humans are, to the physical questions, literally, what are we made of? And how did it get to be here? I loved studying physics, but it did not give me all the answers. Instead, I learned that actually there are many more questions to be answered, and actually that sometimes the more in depth you study a subject, the less you feel like you know, as you begin to realize just how much is out there that you don't know. After my degree and working in a bar for a year, where I didn't get any more physics answers, I did get answers to some other questions, but again, a topic for another time. I went back to take my studies further. This time I wanted to learn about the world of academic research. The subject I entered into is nanotechnology. Nanotechnology is science and technology on the nanometer scale. And this is about as far as you can get from the grand scale of space, because a nanometer is 1,000,000 times smaller than a millimeter. It's very hard to show you what I mean by that. So if you think about your hair, the average human hair is about 70 to 80,000 nanometers across. So on that scale, we need novel methods, innovative means to observe and to interact with things. Whilst working in this field, I became really interested in how different academic disciplines had to work alongside each other, and how individual researchers like me had to find ways to switch between disciplines in order to undertake practical experiments. In my case, I was using physics methodologies to look at the chemistry of bacteria to understand how their biology and their environment interacted with one another. And so, of course, I was based in the Department of Engineering. There you go. It gave me an ability to work with scientists and engineers of different backgrounds and to develop understanding between them in pursuit of a common goal. This is something that people often refer to as cross-disciplinary working. This requires the so-called soft skills. Things like communication, collaboration, cooperation, alongside analytical skills and an ability to quickly, and I mean quickly, acquire technical skills and knowledge. After 11 years of study, it was these skills that brought me back to space. In the space sector, scientists, engineers, and other professionals need to work together closely in order to make sure that their missions succeed. The Apollo 11 mission, which I think most of us, or many of us might argue, is the pinnacle of humanity's achievements, certainly in space to date, resulting in the first ever humans to set foot on the moon, took the efforts, it's estimated, of 400,000 different people working together. People often think of Apollo and the moon landings when they think of space. I spend time talking to young people about STEM careers in science, technology, engineering, and maths. And when I tell them I want to talk to them about space careers, the younger children will usually assume that I'm talking about being an astronaut. And to be honest, if they want to talk about being an astronaut, I'm happy to talk to them about that. Older children might also think that I want to talk about what it's like to be an astronomer, someone who studies things like stars and galaxies, and I'm always happy to talk about that as well. But what young people don't realise, and in fact, I would say most people of all ages don't realise, is how much we already rely on space in our day-to-day lives. The easiest example I can give you is sat-nav, which I'm going to guess that most of us in this room have used at some point. And we're so familiar with it that we forget that it relies on space technology. In fact, most of us probably have a navigation app on our phone, and that is connected to networks of satellites that help us to find our way to our destination. Now, satellites are essential parts of our modern life. They have given us a space-enabled world, and that is mainly through the networks of communication satellites and the navigation satellites, as in the example I've just given you. These circle our planet, they were built on Earth, and they're operated from Earth, and they only exist to facilitate how we live our lives on Earth. But these aren't the only satellites that we have out there working for us. We also have satellites whose sole job is to look at the Earth, record data about the Earth, and then send it back to us. I would kind of give a brief history of this as starting maybe in the 1970s, when scientists and engineers worked together to build weather monitoring satellites. And these are in use to this day, recording data sets that are used by meteorologists to help refine their weather prediction patterns. And those of you who are, a few decades old, maybe 30 or older, will remember how bad weather prediction used to be and how much more accurate it is today. And that is because of the acquisition of that data and, of course, the data processing that goes with it. After weather monitoring satellites, more specialist Earth monitoring satellites were developed. These use a range of different detectors to observe things about our Earth and to send that information back. The detectors can detect things like ocean salinity or sea surface temperature, so that we can understand better the movements of the ocean currents and how that affects different parts of our planet. They also tell us about things like the seasonal changes of the polar ice caps and how that has changed over the years. Things like the health of vegetation, or changes in land use like deforestation or urbanization, all can be monitored from space. Satellites have even observed algal blooms in the ocean, and they've even tracked wildlife. One of my favorite examples being the identification and observation of remote, unknown penguin colonies because of the changing colour of the snow as it became covered in penguin poo. Satellites are already lifesavers. They can be pressed into service after emergencies to work together to give us up-to-date information. Natural disasters like earthquakes, volcanic eruptions, floods, forest fires and landslides can cause escape routes to be blocked or pathways for emergency responders to just disappear, just as those people are trying to get in there to help. Up to the minute, information from satellites can really be the difference between life and death in those situations. All of these satellites are a global monitoring system. It's like an overview kind of comprehensive health check on the Earth. But this global overview can actually be brought down to local level, and there are projects working on this right now. In the Midlands, for example, there's a project which is going to combine lots of different types of satellite data: weather prediction, air quality. It's going to use communication and location systems, so that if you have a health problem that is made worse by poor air quality, you can get an alert and advice so that you can plan your movements to make sure that you're less affected by it, keeping you healthy and safe. There are projects where people are connecting medical professionals by satellites with some of the most remote rural communities where other forms of communication are limited. There's even a field, and you have to forgive me because this is a pun, a field called agritech, which is agriculture supported by technology. And space is a part of agritech too. You can have your crops monitored by satellites, the health of them monitored, and then you can have specific sites targeted based on that information with water or fertilizer delivered specifically to those sites by autonomous vehicles that get their instructions from satellites. I could actually stand here for another 10 minutes and just list various different projects that exist today that already use satellite data to solve problems on Earth. But what I want to do now is to look at what I think is the thread that connects them. I want to look at what connects the scientific inquiry, the what if, with the practical application, the if so. Now, I've already told you I'm a sci-fi fan, and I think that some of the things that I've talked about already sound a bit like science fiction. So I'm going to take a sci-fi approach to asking these questions. What if we had the means to collaborate globally, to gather reams of data about our Earth? What if we had a network of devices communicating with us constantly to tell us what was going on our planet? What if we also had the means to collate and interpret this data to give us insights and trends, maybe a science that was completely devoted to the analysis of data called data science, something that has already been developed and used in many other sectors, and that is increasingly being something that people know about today because of the reams of personal data that we now all generate. What if we humans, who have for thousands of years used tools to shape our environment and who have set ourselves up as stewards of this planet, exploiting or defending resources as we see fit, could use these insights to make better decisions about what we do in our environment and on our planet, both on the scale of continents and nations and on the scale of neighborhoods and communities? What if we decided that this was worthwhile, more than that, vital, not only for life on Earth as it is now, but to safeguard the Earth for future generations, and not just for the rich or people living in rich countries, but to improve the lives of everyone? What if we didn't think that it was just important for life, for the sake of life on Earth? What if we realized that this was something that we needed to do in honor of the whole universe? Because as far as we know, we are all of the life in the universe. As far as we know, there's nothing else out there away from planet Earth. The sum total of human knowledge may be the sum total of knowledge anywhere. Therefore, the fate of the universe may actually depend on the fate of this planet and its people. If so, then we have the information that we need, and we have the reason to act, and we have the power to make informed choices about our future. This is how space can save the world. And it comes down to three things that I think are the process by which we should be taking advantage of the amazing tools that space science and technology has already given us. First of all, share the knowledge. And I mean that both in terms of sharing information about how we already use space and in terms of sharing the information that we gather from those satellites in space. Some scientists and engineers already believe it's important to share this data so much that they're already doing it. For example, some of the European Space Agency's Sentinel Earth Observation Satellite project scientists are sharing their data freely. There might be someone trying to solve a problem here on Earth without realizing that there is satellite data available that might be able to help them. So share the knowledge, tell everyone. Secondly, develop the skills. And I mean that again, in more than one sense. Firstly, develop the technical skills, the engineering capability to build these satellites, the data science skills to manage those huge data sets and turn them into useful insights, but also in terms of the skills to build consensus and have a common approach across companies and nations. Businesses and research departments should be investing in these skills for their staff, and governments should be investing in giving young people the opportunity to develop and learn these skills. The third pillar of this approach depends on the first two. Empower people to make informed choices. So we have this amazing technology. We have this network of satellites looking back at the Earth, and it's giving us reams of data, and we've got people with the skills to analyze that data, and it's giving us insights and trends. But at the moment, it's just monitoring. It's just telling us what's already happened or how things are. This part of the city gets hot, for example, and this part gets cold, or this part of the coastline is eroding quicker than this part. And what are we going to do with those insights? Are we just going to sit on them? Are we just going to observe and wait and see what happens? Or are we going to do something else? We can use the evidence from the information gathered from space to help us make the best, most informed decisions that we can about our environment and about our planet. And we should all be empowered to be part of this conversation and to be part of the decision making on what affects our environment and our planet, the only home, so far as we know, to life in the universe. Now, I think this approach actually also works on an individual level. We all, as individuals, just as much as the human race does, deserve to have the opportunity to make the most of our talents by building our knowledge, developing our skills, and then making informed choices. This is one of the reasons why I think it's so important for young people to be supported and to be educated. Young people deserve to have teachers who will show them that their curiosity is a credit to them, and that if they want to make a difference, they can start by building their knowledge, developing their skills, and then choosing to act. STEM education is vital for young people. They're going to grow up in a world that is powered by technology that we are only just beginning to dream about. They need to have the skills and the knowledge to be able to navigate the choices they're going to have to make in the future. They need this knowledge, they need these skills so that they are not left behind. Something that is already happening to people who aren't able to access some of the new digital world that we're living in. Science belongs to all of us, just as this planet does, even as space does. It is something that is part of all of our heritage. By pursuing knowledge, by using our skills to follow our curiosity, and then by using what we discover to inform our choices about the future, I believe we can build a fantastic future for the human race and for life in the universe. If we ever do properly make it off this planet, if we're ever able to travel between the stars, to journey across unimaginable distances to find brave new worlds, then this planet will be where it all started. There's a saying that goes, "We do not inherit the earth from our ancestors, but we borrow it from our children." Whether they are earthbound or starfaring, their fate will be the fate of the universe. But that fate starts here and now. The fate of the universe starts with us. Thank you.